Welcome to Module 4, Verification versus Validation. These two terms that sound almost identical that beginners constantly mix up and the interviewers love to test you on. By the end of this short module, you will never confuse them again. VNV is one of the most fundamental concept pairs in all of software quality. It appears in the ISTQB syllabus, in interviews, and in daily QA conversations. Understanding the distinctions shapes how and when you test. Everything in this module comes down to two simple questions. Verification asks, are we building the product right? And validation asks, are we building the right product? Same words, different order, completely different meaning. Now let's unpack that. Remember the absence of error fallacy from module 1. So, a product can be built perfectly to specifications and still be the wrong product. That principle is really a story about verification and validation, and this module explains you why. Let's put verification and validation side by side. On the left, there's verification, it says, are we building the product right? And on the right, there's validation, which says, are we building the right product? So verification is about correctness against the specifications. Did we follow the requirements? Does the design match what was agreed upon? Does the code follow standards? It asks, did we build the thing the way we said we would? So crucially, verification does not require running the software. It's about reviewing and checking documents, designs, and code. On the other hand, validation is about fitness for purpose. Forget the spec for a second. Does the actual working product solve the user's real problem? Validation almost always involves running the software and seeing how it behaves. So, imagine you hired a builder. Verification is the inspector checking that the wiring meets code, the walls are the right thickness, the blueprint was followed exactly. Validation is you walking in and asking, is this actually the house I wanted to live in? Are the rooms where I need them? Does it work for my family? You can build a house perfectly to a blueprint and still build the house wrong. So, you can also compare verification and validation by an example of cooking. Verification says, did you follow the recipe correctly? And validation would check if the dish actually tastes good to the person eating it. Both are needed. Verification without validation could be a perfectly built wrong product. And validation without verification could be chaos, no standards, expensive, late stage surprises. Quality requires both verification and validation for a successful product. Let's go deep on verification. The question, are we building the product right? So, verification is what we call static testing. We try to examine and review the work products without running the software. We're reading the documents, reviewing the design, inspecting the code, no execution needed. This can be connected to module 1 about the early testing principle. Verification activities happen early, often before any code can even run. And that's exactly why they are so cost effective. They catch defects at the cheapest possible moment in requirements and design, long before they become expensive coded bugs. So verification shows up mainly as reviews. Let's look at three big ones in order they happen across a project. So the first one is a requirements review, the earliest and arguably most valuable. We sit with the requirements, the SRS, user stories, and check, are they clear, complete, consistent, testable. A vague requirement like the system should be fast gets flagged here and quantified to pages load in under 2 seconds. So catching a bad requirement now costs almost nothing. Catching it after it's coded costs a fortune. Then are the design reviews. Once the design and architecture are drafted, we review them against the requirements. Does this architecture actually support the required 10,000 concurrent users? Are there security holes? Is it maintainable? Fixing a design flaw on paper is far cheaper than ripping out built code. And then the code reviews. During development, peer inspect each other's code before it goes to testing. They look for logic errors, adherence to coding standards, security vulnerabilities, and readability. Studies have shown that code reviews catch 60 to 70% of defects before any dynamic testing begins. So, reviews, these three types, can further be categorized into walkthroughs where author leads peer reviews, peers through the work product information in an informal setup. There could be inspection where formal defined rules are there and metrics are created against which the product or the code is inspected. Then there's peer review, colleagues review each other's work, technical review, where experts assess the technical soundness. Notice that none of these require running the software, and that's the signature of verification static examination of work product. And notice the timeline reviews march along the SDLC phase. Requirements, design, and code. Similarly, requirement review, design review, and code review. Now, part two, validation. The question flips. Are we building the right product? So, where verification was static, validation is dynamic in nature. We actually execute the software and observe the behavior. We run the application, feed it inputs, and check the outputs against what users actually need. Validation generally happens later in the life cycle once there's working software to run. And this is the does it actually work for real people stage. So, validation shows up as dynamic testing, actually running the software. Now, we'll look at two key examples here functional testing and user acceptance testing. So, functional testing is the workhorse of QA. We execute the application and check that all the features are doing the functional requirements like what it is intended to do. Click the button, does the right thing happen? Submit the form, is the data saved correctly? It's typically black box testing. We care about inputs and outputs and not what is happening internally in the code. This is generally done by the QA team and includes integration and system testing. So for a login feature, maybe entering valid credentials should reach dashboard. If you enter invalid password, should show an error. If you enter a blocked account, should deny access. So we validating the feature actually works by running it. The next one is user acceptance testing, which is the ultimate validation. Real business users or their representatives, they use the software in realistic scenarios and they confirm if whatever the software is doing is solving their problem. This is what they needed. UAT is the final gate before we go live. So functional testing checks against the specifications, like does it match what was written? And UAT checks against real needs. Does it actually serve the business? This is why UAT can fail even when functional testing passes. The specification itself might have missed what users truly needed. So that's the absence of errors fallacy from module 1 live in the real world. There are other validation types like system testing, there's integration testing, there's performance testing, usability testing. All involve executing the software, so all are the forms of validation. Now, let's put everything side by side now in one comparison table so that you can memorize one slide from this module to make a clear understanding about verification and validation. So, in verification, the question is building it right versus building the right thing. The word order is the whole difference here. The focus in verification is the process and the intermediate work products. On the other hand, for validation, it's the finished product. The method used in verification is static, while in validation, it is dynamic. The timing of verification is early and throughout continuous. Validation generally happens later after we have something to run. Verification is performed by reviewers, developers, analysts, QA, and validation would be performed by the end users, QA team, or the clients. The findings of verification could be defects early in the documents, and validation could catch defects for the actual behavior in the behavior and fit. So, here's a quick trick that will never let you forget what is what or which one is which. Verification is review. Static, you are reviewing, and validation is real use, running, dynamic, real users, runtime, or simply verification is right, is it correctly built, or validation is right product, correct thing is being built. So interviewers might try to trip you up. Is code review verification or validation? Verification is a static review, no execution. UAT verification or validation? It's validation because we're actually running the software. So practice these until they are instant. Just try to understand or divide on which type of testing is verification or validation. Now, there's a classic SDLC model that perfectly illustrates how verification and validation relate, the V model. We touched on it in module 2. Now you will see why it is shaped like a V. So the left arm going down is the verification side, the build activities, the requirements, system design, architecture, module design. Each step is verified through reviews. At the bottom point is coding. Then the right arm going up is the validation side, the testing activities like unit testing, integration testing, system testing, and acceptance testing. So here's the genius of the model. Each build phase on the left has a corresponding test phase on the right at the same level. Requirements have acceptance testing, system has system testing, architecture has integration testing, module design has unit testing. So the test on the right validates the work done on the left at that level. So the V model bakes in the early testing principle. The moment you write the requirements, you also design the acceptance test. When you design a module, you design its unit test. Testing is not bolted at the end, it's planned in parallel with every build activity. And that's verification and validation working as partners. Safety critical industries like medical devices, aerospace, defense, they love the V model because every build artifact is explicitly verified and validated. Now, you can use some of the tricks or distinctions with some memory aids that are present in this slide. So, if we talk about the word trick, verification is review. It's static, you review. It has VI. The validation has L, the real use, running it for real. Silly, but it sticks in someone's mind. If we talk about the house analogy, verification is, did the builder follow the blueprint exactly? And validation is walking in and asking, is this actually the home I wanted? You can nail the blueprint and still build the wrong house. Both are essential. Verification without validation is a perfect wrong product. So this is the maturity point. It's not verification or validation. It's both. Verification alone will give you flawlessly built product that might be completely wrong, and validation alone will give you something users like but with no engineering discipline, full of late expensive surprises, and quality needs both that work together. Now let me give you the two questions that trip up almost everyone. Is code review verification or validation? Verification. It is static. No code runs in code review. Is UAT verification or validation? It is validation because real users, there's real execution. Drill these. If you can answer instantly and explain why behind it, you'll impress any interviewer. So, with this, we come to the end of the module 4. So, verification is building it right, static reviews, no execution, validation is building the right thing, dynamic testing, real execution, verification example could be requirement design and code reviews, validation examples can be functional testing and UAT. Both are essential. The V model pairs every build phase with a test phase. So, when someone stops you in the hallway and asks for the difference in one breath, verification checks we built it right. Through reviews without running it, and validation checks we built the right thing by running it for real user. That's it. So, if this finally made verification versus validation click for you, hit like and subscribe. It genuinely helps the channel reach more students. Share it with anyone prepping for QA interviews because this is one of the most asked topic out there. And comment below which analogy worked best for you, the house, the recipe, or the word trick. I read every comment. Thank you for watching. See you in the next module. We'll talk more about some the test principles. Keep learning, keep testing, and remember, build it right and build the right thing. Thank you.